friends, welcome back to my channel Science Kids. In the last video, we discussed about atoms. We also learnt about the structure of an atom. If you haven't watched the video yet, please do so by clicking the link given in the description. Before we move on, let's go through the question I had asked you at the end of the previous video. Why we can't convert lead or any other element into gold. In fact, we can turn lead into gold by nuclear transmutation. Nuclear transmutation is the conversion of one chemical element into another chemical element by changing the number of protons and neutrons. It takes place naturally in the sun, where hydrogen is converted into helium. But turning lead into gold by artificial methods is really difficult and complicated. This is because the subatomic particles hold the protons and neutrons tightly together. In order to separate the protons and neutrons, immense amount of energy is required. In 1980, scientists finally transmuted a minute quantity of lead into gold. Nowadays, we use particle accelerators such as the Large Hadron Collider to transmute one element to another. Particle accelerators use magnetic fields to speed up alpha particles and focus them into the nucleus of an atom. The alpha particles collide with the nucleus and knock off the proton or neutrons out of the nucleus. But this process requires enormous amounts of energy and is not cost effective. Now let's move on and learn about elements. Friends, do you know how elements are formed? Groups of similar types of atoms form an element. An element is a pure substance, that is, it cannot be broken down into other types of substances. To understand the concept of elements better, let's study about the process of electrolysis. Water can be split into hydrogen and oxygen by the process of electrolysis. In the above setup, two metal plates are used, one made of steel and the other one made of iron. The two metal plates are called electrodes. An electrolyte is a substance that produces an electrical conducting solution when dissolved. A small amount of electrolyte is used, such as dilute sulfuric acid. The electrolyte is necessary because pure water doesn't conduct electricity that well. We will learn more about electrolysis further in the video. For now, just remember that electrolysis is the breakdown of substances by passing an electric current. Let me ask you a question now. Here I have listed a few substances. Can you identify the elements in this? Let's look at the first example, water. We have already learned that water molecule is made of hydrogen and oxygen, so water is not an element. Now let's take the second example, oxygen. As shown in the figure, oxygen is made of similar types of atoms, hence it's an element. Let's see the next example, table salt. We can see that the chemical name of salt is NaCl, that is, salt is made of two different substances, sodium and chlorine. Hence, it's not an element. Let's take a look at the last example, chlorine. Chlorine is an element because it is made of similar atoms as shown in the picture. Now you might have wondered how many different types of elements are present in this world. So far, scientists have discovered that there are 118 different types of elements. Imagine how hard it would be to classify all the 118 elements. To solve this problem, a scientist called Dmitry Ivanovich Mendeleev placed the elements in a table. Not this table, but the periodic table of elements. At that time, not all the elements were discovered, but he left places for each element. Elements can be classified into two types, metals and nonmetals. The Hayes-Mcdaniel line in the periodic table separates the metals and nonmetals. The 7 rows of the table are called periods. The 18 columns are called groups. The vertical columns in the periodic table is called a group and the horizontal row is called a period. Now look closer at an element. Do you know what are those numbers representing? The number on the top of the element is called the atomic number. The atomic number is the number of protons in an element, and the number written on the bottom of the element is called the atomic mass number. The atomic mass is the sum of the individual masses of the protons and neutrons. And finally, the name of the element is written as a symbol in the middle. Let's move on and study about ions, isotopes, and isobars. First, let's learn about ions. There are two types of ions, cations and anions. When there is a lack of electrons, the atoms become positive, hence, it's called a cation or a positively charged ion. When there are more electrons than protons, the atom becomes negative, hence, it is called anion or negatively charged ion. Let's take the example of electrolysis of water. When an electric current is passed through water using a metal plate, the water loses electrons, becomes positive, and gets attracted to the negative plate, that is the cathode. The atoms that gain electrons become negative and get attracted to the positive plate, that is the anode. From this, we can say that opposite charges attract each other. Ions also help in bonding between molecules. These bonds are called ionic bonds. An example for ionic bond is sodium chloride or table salt. Now let's learn about isotopes. Have you heard about deuterium and tritium, which are used in nuclear power plants to produce electricity? These substances are called isotopes of hydrogen. Let's understand in detail about them. Atoms having the same atomic number but different mass numbers are called isotopes. The isotopes of hydrogen are protium, deuterium, tritium. All the isotopes of the same element have the same chemical properties but different physical properties. Almost all elements are mixtures of isotopes. The isotopes of uranium are uranium 235 and uranium 238. Let's move on to isobars. Now we know how an element is represented in the periodic table. Now try to represent the isotopes of argon, potassium, and calcium using the atomic number and the mass number given here. But if you see closer, you might find something interesting. The mass numbers are the same in each of the cases. Elements that have the same number of nucleons or have the same mass number are called isobars. We have come to the end of today's lesson. Hope you all enjoyed. Please like, share, and subscribe to enjoy more exciting videos from Science Kids.